For question 1 on problem set 2, we're given the two structures A and B that are isomeric with each other, however that they have different total electron counts, formal oxidation states, and DN electron counts. For species A, we see that it has a total electron count of 16. The metal is in the 2+ oxidation state, and that means that it has a D6 electron count. However, when it interconverts with species B, we find that species B has an 18 electron total count, which means that the metal is in a 4+ oxidation state and has a D4 electron count. And so then when we apply that difference to the part D, we see that we have these two species, C and D, and we're trying to determine which one will be interconverting in between the cis and trans isomers more quickly. And if we think about what we saw in A and B, we can see that the interconversion will likely happen through the metallo-like cyclopropene structure or something like that. And so in order to form that structure, in order to form the intermediate for either of these, we have to have the species undergo an oxidation. But when we do the initial electron counts for species C and D, species C has 16 electrons total electron count, and species D has 18 total electron count. So therefore, only C will be able to undergo an oxidation like more easily, going from 16 electrons to 18 electrons, to form that necessary intermediate for the interconversion of the cis and trans isomers. Species D is already at 18 electrons, and so it's going to be much more difficult to oxidize species D into the necessary intermediate for that interconversion. And so for that reason, C is going to interconvert between the two much faster.